Welcome to a lesson with Dr. Powell. Let's discuss how we can write a composition of two maps or functions between Z modules. Suppose that we have one that goes from Z3 and it goes over to Z2 and maybe another one that goes from Z2 to Z2. Okay, so let's look at, we have a function here, maybe we have a function here. Suppose that we take the standard basis elements E1, E2, and E3, and these ones have different images. Let's suppose E1 gets sent to 0, 1. Maybe E2 gets sent to 2, 3. And let's suppose that E3 gets sent to 1, 1. Okay. Next, suppose that G has an action where it sends E1 to 0, 2, and E2 it sends to 1, negative 1. Okay, so let's think about the composition of these maps. G of F, putting them together from here to here. This will be a map from Z cubed or Z3 to Z2. And how are we going to represent it as a matrix? Well, let's see. First, let's think about F. F can be represented in a matrix thinking about, so let's do it right here. Thinking about that the what's in the image is going to be represented as columns in Z2. So there's going to be 2 rows. And we're going to have a column, so an image element for each basis element of the domain. The domain has 3 basis elements. Each column stands for a basis element, and then you're taking the image of it. So this one goes 0, 1, E2 goes 2, 3, and E3 goes to 1, 1. So this is the matrix which represents F. Similarly, we can write down a matrix for G. This time we only have 2 basis elements in Z2. And again, the image is in Z2, so it's going to have columns of size 2. So we're going to have 0, 2, and 1, minus 1. How do we represent the composition of these maps? Well, the composition, let's see, should have it has outputs in Z2, so we're going to have columns again that are too large. Now, what's the input? What's the domain? The domain of the whole composition is actually Z3. So again, it's going to look like E1, E2, and E3. And what goes in the columns is what we're going to try to figure out. Keep in mind, what goes in the columns is simply G of F of E1. So it's the image, G of F right here. That's going to be that column. This column right here is going to be G of F of E2. And this column right here will be G of F of E3. So we just need to see where each column is taken. So how do we find E1? Well, we simply take E1 and see what its image is via G. Basically, we just plug this. We plug in the image of E1, that is, sorry. We plug in the image of E1, which is 0, 1, and we take 0, 1, and then we plug it into G. So we go E1 to its image, and then that into the function G. So how do we do it in the function G? Remember, we just take 0 times the first column plus 1 times the second column. Well, that's just going to be the second column in this case. So if we were writing this out, the ultimate destination of E1 via here is just simply going to be 1 minus 1. What's the ultimate destination of E2? Well, E2 goes to 2, 3. Then 2, 3 goes into this function, which just means 2 times first column plus 3 times second column. So, that's like adding together 0, 4 plus 3, negative 3, which turns out to be simply 3, 1. And lastly, 1, 1. Let's see, E3, what is that going to do? So E3, where is that going to go? It's going to go to 1, 1, and 1, 1 is going to go into the function g. That just simply means adding the two columns together, which means we're going to get 1, 1. And this right here is the matrix which represents the composition of these two functions. Now, if we were to put a multiplication symbol between these two matrices, that multiplication symbol simply means composition of functions. We use the symbol multiplication with matrices to represent composition. A matrix is simply a function that preserves modular structure. So, and the composition is what the matrix multiplication is. Notice that we could have done this in a myriad of ways. Normal matrix multiplication means we take row and column. 0 times 0, 1 times 1 is 1. 2 times 0 plus negative 1 times 1 is negative 1. Then we take 0 times 2, 1 times 3. That's added together, that's 3. Then 2 times 2 is 4, plus negative 1 times 3, that's 1. 0 times 1 plus 1 times 1, that's 1, and 2 times 1 plus negative 1 times 1, that's just 1. Notice it's that what I just went through right there with row and column, row and column, row and column to get here and here, row and column to get here and here, is the standard way of thinking about matrix multiplication that is taught normally. However, this picture of what's happening via functions and composition and what's going into what, and this matrix representing images of basis elements is very instructive. Thanks for watching.